Here are the answers for the section 7-2 homework. On page 258 oral, we're asked to write a polynomial equation where the square root of 3 would be one of the solutions to that equation. So if the square root of 3 is a solution, that means the original equation could have been x squared equals 3. Imagine how you would solve that. You would take the square root of both sides, getting x equals the square root of 3. Next up, subtract 3 from both sides, getting x squared minus 3 is equal to 0. And here is our polynomial equation in standard form. Number 3, let's make an equation where the cube root of 9 is one of the solutions to the equation. If the cube root of 9 is a solution, then that means the original equation could have been x to the third power equals 9. Again, think how you would solve this. You would take the cube root of both sides, getting x equals cube root of 9. Then subtract 9 from both sides, getting x cubed minus 9 equals 0. And here's our equation in standard form. Number 13, we're asked to identify possible rational roots. To do this, we're going to use the rational root theorem. It involves using factors of the leading coefficient and factors of the constant term. The leading coefficient is a 1, the constant term is a -7. To find possible rational roots, you take all of the factors of the constant term and divide them by factors of the leading term. The factors of -7 are positive and -1 and positive and -7. These are the four integers that divide into -7. The factors of our leading term, which is a 1, are positive and -1. Now, let's evaluate all the actual numbers created from different combinations of numerator plus denominator. If we choose 1 for the numerator and 1 for the denominator, we would have 1 over 1, which is 1. But if we choose -1 in 1, we would get -1. As another combination of numbers, let's work with the 7s. One possibility is +7, and another possibility is -7. These are the four numbers that are created by evaluating all the possible combinations of numerator and denominator. Now, we weren't asked which of these are actually solutions to the equation. We were simply asked, what are the possible rational roots of the equation? Number 15, the leading term is 1 and the constant term is 11. So our possible rational roots have all the factors of the constant term divided by all the factors of the leading term. Now let's figure out what the numbers actually are. We could get +1 or -1, and we could get +11 or -11. Again, I'm not saying that these are the answers to the equation. It's just these are the possible answers that are rational. Number 17, here's the leading term and here's the constant. So the possible rational answers will come from the following list. Positive and -1 are factors of -3, and positive and -3 are factors of -3. In the denominator, it must be factors of the leading term. Positive and -1 are factors of 2, and positive and -2 are factors of 2. Now let's figure out what numbers this actually produces. We could have 1 or -1. We could have 3 or -3. We could have 1/2 or -1/2. And if we put the 3 on top of the 2, we could have 3 over 2 or -3 over 2. Page 259 written, we're asked to solve the equation. A complicated equation like this with many terms shows why knowing what the possible rational roots are is helpful. So let's first think about our possibilities. Factors of negative 4 are positive and negative 1, positive and negative 2, and positive and negative 4. Factors of the leading term of 1 are positive and negative 1. The actual numbers produced by this are positive 1 or negative 1, positive 2 or negative 2, and positive 4 and negative 4. We're asked to solve it using only rational numbers, so any rational numbers that work must come from this list. Let's substitute them in one at a time until we find any that might work. Start by filling in 1. We would have 1 cubed minus 2 times 1 squared plus 5 times 1 minus 4. Does that equal to 0? Does that solve the problem? 1 cubed is 1. 1 minus 2 is negative 1. Negative 1 plus 5 makes 4, and 4 minus 4 makes 0. Yes, the number 1 is a rational root. Now let's fill in negative 1 and see if that works. We're wondering, does that equal 0? Negative 1 cubed is negative 1. Negative 1 subtract 2 is negative 3. Negative 3 minus 5 is negative 8. And negative 8 minus 4 is negative 12. This is a no. Now let's try 2. 2 cubed is 8. 8 minus 8 is 0. 0 plus 10 is 10, and 10 minus 4 is 6. This is no. Now let's try negative 2. Negative 2 cubed is negative 8. Negative 8 minus 8 is negative 16. Negative 16 minus 10 is negative 26. And then minus 4 is negative 30. This is a no. Now let's try 4. 4 to the third power is 64. 64 minus 32 is 32. 32 plus 20 is 52, and 52 minus 4 is 48. This is a no. Finally, let's try negative 4. Negative 4 cubed is negative 64. Negative 64 minus 32 is negative 96. Minus 20 is a lot more negative, and then minus 4 is even more negative. This does not make 0. This is a no. Our only rational number is the number 1. There are other solutions to the equation besides the whole number 1, but 1 is the only rational solution to the equation. Number 17, solve over the set of rational numbers. For number 17, let's put this in standard form by getting a 0 on the right side. Subtract the 14z and add the 24. Now let's make a list of possible rational roots. All of the factors of the constant term 24. Positive negative 1, positive negative 2, positive and negative 3, positive and negative 4, positive and negative 6, positive and negative 8, positive negative 12, and positive and negative 24. These are all the numbers that divide into 24. Then in the denominator, all of the factors of the leading term, which is a 1. So just positive and negative 1. When you divide all the numbers in the top by these choices for the denominator, you're going to get all these numbers in the top, just integers, no fractions. So I'm not going to rewrite this list of numbers. One or more of these numbers might be rational solutions to this equation. We need to try something, so just pick something to start with. I'm going to choose 2. And substitute 2 in place of z. So 2 cubed minus 2 squared minus 14 times 2 plus 24. And I'm wondering, does it make 0? So 2 cubed is 8. 8 minus 4 is 4. 4 minus 28 is negative 24. And negative 24 plus 24 does make 0. This is a yes. The number 2 is a rational root. Maybe 3 is also a rational root. Let's find out. Plug 3 in place of z. Does this make 0? 3 cubed is 27. 27 minus 9 is 18. 18 minus 42 is negative 24. And negative 24 plus 24 is 0. This number also works. So far we found 2 rational roots. Because this goes to the third power, there will be 3 roots. So the third one that we haven't found yet might be rational, and if so, it would come from this list. We need to try plugging in other numbers from this list until we find another one that works. If we plug it in and we end up with a no, just try something else. After some false starts getting some no's, I found out that negative 4 does work. Let me show you why. When you type this in the calculator, this does make 0. Here are our 3 rational solutions to the equation, 2 and 3 and negative 4. When I did the problem, it's not like that I only tried those 3 numbers and lucked out that those worked. I did have some numbers that I tried, and I found out that the answer was no. For the review assignment, we're given an equation, and we're asked, what are the restrictions on x? There is a variable inside of a radical, but the radical is an odd indexed radical. So it's okay if this is negative. So this one has no restrictions. Page 255 written, we're asked to solve the equations, again, using only rational numbers. So let's divide by 64 on both sides, getting y squared equals 121 over 64. Then remove the squaring by doing square root. Because we're doing square root, which is an even indexed root, there will be 2 answers, positive and negative. The square root of 121 is 11, and the square root of 64 is 8. Number 20, let's add the 343 to the right side. And then divide by 27. Then remove the third power by doing a cube root. It's okay to leave the answer like this unless we can actually find the cube root of 343 and the cube root of 27. Let's use the calculator to find the cube root of 343. You can use the cube root button, or we can use a future topic that a cube root is the same thing as a 1/3 power to figure out what 343 to the 1/3 exponent would be. Similarly, in the bottom, you can find the cube root of 27 by using the cube root key on the calculator, if it has one, or you could type 27 to the 1/3 power. It's a future section where we'll learn that a 1/3 exponent is the same thing as cube root, or that a 1/2 exponent is the same thing as square root. On a calculator, we find out that 343 raised to the 1/3 power is 7, and 27 to the 1/3 power is 3.